Now we will use the thumb rule to design the hot water circulation system for this building, having plumbing fixture, shower 65 number, dishwasher 40 numbers, kitchen sink 55 number, lavatory, wash basin 130 numbers. This is the electric water heater supplying hot water to the building through this hot water piping, and this is hot water recirculation piping, for which we need to select the pipe size and hot water recirculation pump. Now for these plumbing fixture, we will select the fixture unit value for hot water from International Plumbing Code. For dishwasher we have 1.4 fixture unit. For kitchen sink that is private type, we have 1 fixture unit value. For lavatory private type we have 0.5 hot water fixture unit value, and for shower head we have 1 fixture unit value for hot water. Now after multiplying the selected fixture unit values with their quantities for all the plumbing fixture in the building, we get total fixture unit number 241. For thumb rule we follow these assumptions. For each riser of size from 3/4 to 1 inch, we count half GPM for recirculation. Number 2, for each riser of size from 1 1/4 to 1 1/2 inch, we count 1 GPM for hot water recirculation. Number 3, for each riser of size 2 inch and greater, we count 2 GPM for hot water recirculation. Number 4, for each group of 20 hot water supply fixture units, we count 1 GPM for hot water recirculation. As we know, for every 20 numbers of hot water fixture unit, we need to provide 1 GPM of hot water recirculation. So for 241 number hot water fixture unit, we need to provide 241 divided by 20 equal to 12.5 GPM recirculation of hot water. So 12.5 GPM is the discharge of hot water recirculation pump. Now we'll select the pipe size and pressure drop in this pipe. Our GPM value is 12.5. You can see in this chart, horizontal are the GPM values and the vertical are pressure drop in PSI per 100 feet. These lines are for velocity. This 1.25 feet per second, this 2.5 feet per second, this is 5 feet per second, and this 10 feet per second. And these lines are the pipe sizes. This 12 inch, 10 inch, 8 inch, 6 inch, like this, and this up to 1 1/4. Now we will draw a line on 12.5 GPM. And for hot water system, we know that the maximum velocity we have 5 feet per second, so we will draw a line on 5 feet per second. Now we need to select our pipe at 5 feet per second or at lower velocity. So you can see the GPM line is intersected with the pipe size line here. It is the smallest pipe size, 1 inch. Then it is intersecting here. This is 1 1/4 and 1 1/2 inch. So we'll select the 1 inch pipe size. These horizontal lines are for pressure drop. So we can see this GPM line is intersecting the pipe size 1 inch at, you can see here. So if we take it, it is nearly 4.25 PSI per 100 feet. So we will select the 1 inch pipe at the rate of 4.25 PSI per 100 feet. Now we will calculate the total pressure drop. We have selected pressure drop in 1 inch copper pipe 4.25 PSI per 100 feet, and total effective length is 750. So when we multiply these values, we got the result total pressure drop equal to 31.875 PSI. Usually the pump is oversized by 10% of head and 5% of flow. So when we will add 10% to the flow, then the pressure head of the recirculating pump will be 35.06 PSI, and when we will add 5% to the flow, then the flow of recirculating pump will be 13.13 GPM.